Hi everybody, this is Mrs. Costello. I'm doing day 7. It's our very last day. We are kind of combining absolutely everything that we've been doing this unit. So it is a tough day, but I know that you are more than capable of doing it. So we are going to be working with those rational exponents again. So for those of you guys who are like, fractions are not my jam, I am so sorry. I understand totally, but we're going to have to work with some fractions today. So let's kind of, review. Okay, how do we deal with fractions? So when we're adding or subtracting fractions, so those first two blanks in the box, to add or subtract fractions, get a common denominator. I do not know if I can fit that in that blank, but let's try. Common denominator. Okay. And when I'm talking about denominator, I'm talking about the bottom. Okay. Now, when I'm making a common denominator, I'm going to do that by multiplying the numerator and the denominator by the same number. Okay, and don't worry, I will walk you through some of these, so we're going to be fine, I promise. Then once you've done that, we are going to add or subtract the numerators, or I call them the tops. We're going to hear both throughout this video, so don't worry about it. The numerators, and you keep the denominators. Okay, think of it as like a pizza. When we cut a pizza into, 6 pieces, there's always so many pieces out of 6 pieces, but we never changed that we had cut our pizza into 6 pieces. When we're multiplying fractions, to multiply fractions, you multiply the numerators and the denominators, or tops times bottoms. That's how I'm gonna say it. So, okay. All right, we're just gonna finish filling out this vocab box. Okay. And then we're gonna put some of this vocab to the test and some of our exponent rules to the test, because we've been doing exponents this whole time. All right. So simplify, and we're going to write our answers in exponential form and radical form. So don't worry, I'll help you with that radical form. All right, let's look at number 1. So number 1, we have two numbers that have a base of 2, they're being multiplied. So I know when something looks like this, I know that my exponent rule is I add those exponents together. So I'm going to rewrite the base. So 2 and then 1 to the 1/5 plus my other exponent is 3/5. So I am going to check if I have common denominators on my fraction. And I do. I have 5s. So we can go ahead and add those tops together. So 1 plus 3 is 4. So 2 to the 4 over 5. Now, this is one part of my answer. This is that exponential form because it still has an exponent. Now, to go to that radical form, we have to put the 2 inside a little radical jail. That's what I call it. And the top number tells you how many times to write the 2. So 2 to the 4th, there's going to be 4 2s in there. And then the bottom number is your radical number, or, groups of that number. So the 5 goes on the outside of the radical. Okay. I'm okay with this. Your teacher might want you to actually put 2 to the 4th in your calculator. So that's 2 times 2 times 2 times 2, which is 16. So this is your radical form of the problem for number 1. For number 2, I've got a 7 to the 1/6 on the inside, and then that 4 is on the outside. So that's that power to a power rule, because I got parentheses, and then I have to bring that 4 in, right? Power to power. Now, when you're timesing a whole number by a fraction, the whole number goes on top and gets multiplied to the top number. So 7 is still the base, and then 4 times 1 is 4 over 6. Okay. All right, before we start, doing some radical form, I think we can make that fraction smaller. We always want to work with the smaller fraction, trust me. So 4 and 6 can both be divided by 2. So 4 divided by 2 is 2. 6 divided by 2 is 3. Let's roll with 7 to the 2/3. That's our exponential answer. Our radical answer is, I'm going to put the 7 under a radical jail. Remember, the top number tells me how many times to write it. So I'm writing it 2 times, so 7 squared. And I need groups of 3. The bottom number is your root. Okay. Now, again, your teacher might want you to actually put 7 squared in your calculator. I know I probably do. So 7 squared is 49. Use rainbow pen for this. So cube root of 49 is the radical form. Okay, so you do need both on these ones. Let's take a look at number 3. Number 3. Looks like we're going to use our quotient rule, and our quotient rule means we are going to be subtracting. So I am going to write it out because they're fractions, and it's just going to be better for me to see it. So I'm going to keep my base of 3. My first fraction is 5 over 8 minus my second fraction is 1 over 8. Ooh, this one's going to be good. I just know it. Okay, so when check for common denominators, they both have an 8, so we're good to go. And 5 minus 1 is 4, so 3 to the 4 over 8 is my fraction right now. Ooh, that 4 is ugly. Sorry, friends. Hold on. Can't have that. There we go. Okay. Now the 8's ugly. You know what? You're fine. Okay, let's make that fraction as small as we can. So 4 over 8 is actually 1/2. So I'm going to write 3 to the 1/2. And I like that better because I know, like, when I go to do my radical form, it's going to be a lot nicer. So let's make our little radical jail. 3 goes in. It's only going in one time because my top number is 1. And I'm doing a group of 2. Now, I personally don't care if you put a 2, where it's supposed to go. But you don't need it because square root automatically tells us groups of 2. Hopefully you remember that from last unit. Right. So here's the deal. On A, normally when it's a letter, I'm like, oh yeah, you guys are good. Do your thing. Have fun. Whatever. But I'm going to set up A for you. Then you're going to finish A. So kind of like number 1, right? I've got 2 things being multiplied together. I know I need to add those fractions. So keep your base of 10. My first fraction is 2 over 7, plus my second fraction is 5 over 14. Do I have common denominators? That is a no. I have a 7 and a 14. I can make common denominators, though, because I know I can turn that 7 into a 14. If I just multiply by 2. So I'm going to, on my first fraction, I am going to multiply by 2 over 2. Now you have to do the top number versus the bottom number. You have to do both. You can't just do the bottom number because that changes things. Like if you're now going to cut your pizza into 14 pieces, like the piece that made 7, like, right? If I cut my pizza into 7 pieces, I have now cut that single piece into 2 pieces, which is why we got to change it. So 10 and then 2 times 2, right? We go numerator times numerator, so tops together. 4 over 7 times 2 is 14 plus 5 over 14. Right. So I feel like you guys could take some time and finish this one on your own. Actually, you know what? No, never mind. Change my mind. Sorry. Go ahead and add those. So 4 plus 5 is 9 out of 14. So 10 to the 9 out of 14. and I need that radical form. So this is my exponential form. My radical form, 10 goes in radical jail. The 9 on top tells me I have 9 tens, and the 14 on the bottom tells me groups of 14. Now listen, if you decide to put 10 to the 9th in your calculator, it's going to be a huge number. So sometimes you do not have to put them in your calculator. I am personally fine with this, but check with your teacher to see if they're fine with that. So those are your two answers on A. Okay, this time I definitely put my full trust in you people. You can do B and C. I know you can. So go ahead and pause your video now and do B and C. All right, here's what I got for answer B. So my first box, you should have multiplied those fractions. So multiply the tops, multiply the bottoms. Should have gotten 6 to the 1/3 after you reduced. 1/3 means I write 6 one time in a cube root. So my boxes are around my two answers. So check your work on B. Here's my work on C. I needed some common denominators there, so I did it. And yeah. So you should have gotten 5 to the 2/3 for your exponential and then turned it into cube root 5 squared. And you could do 5 squared in your calculator, so I went ahead and simplified it. So again, check your work. If you're not sure where your work went wrong, you can ask your teacher in class tomorrow. All right. Number 4, we are going to do together. All right. When I have something like this, I definitely look inside and go, okay, can I do anything at all to make this fraction a little bit better? So when I look at number 4, I've got my 27 on top, but I have no more numbers. So I'm going to go ahead and write 27 because I'm not going to do anything with the 27. Okay. Now, with the x's, I've got x's on top and x's on the bottom. So I'm going to go ahead and take away the smaller x. So I have x to the 8 versus x squared. Let's take away 2 x's because x squared is smaller. So take away 2 x's here. Take away 2 x's, so I have x to the 6th left. And I'm going to do the same thing with the y's, because look at that. I've got 12 y's on top and 9 y's on the bottom. So I'm going to go ahead and take away 9 y's on the bottom and 9 y's on the top. So that means I have y to the 3rd left times 1/3. All right, so there's a couple ways of doing this, and your teacher might do it a little differently than I do. What I do instead of distributing that 1/3 is I take this whole thing and I just go ahead and make it in its radical form. So what I do is I go, okay, I need to write this whole thing one time. Okay, so I'm going to do that. Put my little radical jail going up there. So 27, x to the 6th, y to the 3rd. And I am looking for groups of 3. Okay. Now, the reason why I do this is, guess what? We can simplify these. So we need to. 27 looks like we're looking for groups of 3. 27 is 9 times 3. I'm just going to keep rolling with this. 9 is 3 times 3. Okay, there's my group of 3 with the 3's. So these guys are going to break out. Awesome. Now with the x's and the y's, I like to write them out. So I have 6 x's, so I'm going to write 6 x's out. 1, 2, 3, 4, 5, 6. Put them in groups of 3. Look at that. I have 2 groups. And the last thing I'm going to do is do that with the y's. So there are 3 y's. So 1, 2, 3. There is one group there too. So when I'm writing my answer, I have 2 groups of x's. So we're going to write that as x squared. And then one group of y's. So write that as y right there. Awesome. That's how you do number 4. Why don't you give it a try on D? Okay. Pause your video and do letter D now. All right. There's my work on letter D. Everything should have had a big jailbreak. You wrote 36m to the 4th n to the 10th once, and you were looking for groups of 2. So what I put in the rainbow box is 6m squared n to the 5th. Check your work, ask your teacher if you're not sure about some things. Alrighty. E. We are going to do E together because E can honestly be a little tricky. So if you look at E, remember that we want to fix our inside of our parentheses first before we start, putting stuff everywhere. You know what I'm saying? So let's go ahead and look at the inside. So I have 42 over 6. Can 42 be divided by 6? Yes, it can. 42 divided by 6 is 7. Okay. So the 7 is going to stay on top. Now, I'm going to do exactly what I just did on the last one. Let's find, I've got x's on top, x's on the bottom. X to the 4th is the smaller x. So I'm going to take away 4 x's on top and 4 x's on the bottom. That leaves me with 2 x's on the bottom. So I'm going to write x squared. Okay. On our y's, we got to be kind of careful because look at the y's. The y has a -2. To get rid of that negative, it's got to go to the top. Okay, so y squared goes to the top. And on our z's, we've got 7 z's on top, 5 z's on the bottom. So we're going to take away 5 z's from each guy. Take away 5 z's, take away 5 z's. All right, so I have z squared on the top. And this is all being raised to a power of 1/2. Okay, so again, rather than distributing your 1/2 to everything, what I'm going to do is we're going to just go ahead and put it in its radical form on top and on bottom, and let's see who we can break out. So the 1 means I write it once, so radical 7y squared z squared 1 time over radical x squared 1 time. The bottom tells me I'm looking for groups of 2, so I don't need to put a number out there, honestly, unless it helps me. So 7 is 7 times 1. There is absolutely no way I am going to get a group of 2 from 7. But the y's and the z's and the x's, oh yeah. Okay, there are 2 y's, so 1, 2. Cool, group of 2. Z's, let's talk z's. There are 2 again, z and z. Okay. Another group of 2, sweet. So the top is good. If you want to go ahead and write y, z, and then the 7, it's stuck in jail. You're good to go there. Now the x's, same thing. There are 2 of them, so write 1, 2. Look at that, they make a group of 2. Everybody's free on the bottom. And we don't have to rationalize that denominator, so we're pretty happy, honestly. Okay, we're going to do 2 more together, then I'll have you pause your video and do some more. So, number 5, this is something I haven't seen yet. I am starting in radical form. Now, I can't put these guys in the same radical because one of them, this guy, is a group of 2 radical, and this guy is a group of 3 radical. So what we're actually going to do is we are going to change this to their exponential form. So we're going to write 2 to the 1/2 times 2 to the 1/3. Now this looks like something we've done. Like we can totally add those fractions together now because that's our exponent rule. So I'm going to write 2 to the 1/2 plus 1/3. I'm supposed to add them, so I need to check for some common denominators. And shoot, I don't have them. So, gotta make common denominators. let's turn those guys into 6s. So, hold on. Sorry. So I'm going to times the first one by 3 over 3 and the second one by 2 over 2. Sorry, 2 over 2. There we go. Okay, so I have 2. 3 times 1 is 3 over 6 plus 2 times 1 is 2 over 6. Now we can add them because I have common denominators. So 3 plus 2 is 5. So I have 2 to the 5th over 6. That's my exponential, but remember I want the radical form. So put the 2 in jail. Looks like it needs to be in there 5 times, 5 2s, and groups of 6. So 2 to the 5th we can definitely put in our calculators. It is 32, and then we're going to leave it to the power of 6. So this guy and this guy are my answers on number 5. Right. Number 6. Things get kind of challenging on number 6. We've got 2 numbers inside. Now, they do not have the same bases. So normally we can't really use our exponent rules. But I know that 4 is really 2 times 2, or 2 squared. So here's what I'm going to do. We're going to keep our first 2 to the 1/3 just like it is. We're going to times it by, let's change this 4 into 2 squared. But look, I have that 1/3, so we do have to times that 2 by that 1/3. Kind of crazy. I know. This is where it gets really difficult, so it's okay. Be patient. Now I have the same bases, but let's clean this up first before we do anything else. So that 2 to the 1/3 is fine, times the big number goes on top, so 2 times 1 is 2, and then over 3. So 2 to the 2/3. All right. Now I know I'm supposed to add those fractions, right? Because I'm multiplying. So I see that I have 2 to the 2 plus 3, or 2 plus 1 is 3, my bad, over 3. 3 over 3 is just 1. So 2 to the first, which is just 2. So looked really scary, ended up honestly not being that bad. All right, guys, go ahead and give it a try. Why don't you do F and G on your own? So go ahead and pause your video and do F and G. All right, here's my work on F and G. On F, you should have gotten 5 to the power of 3 over 4, and then turned that into the 4th root of 125. Check your work, make sure it looks good. Then on G, we can't add those exponents because x and y are different bases. So I just wrote them as x to the 1/3, y to the 1/3, and then put x and y in 1 cube root. Again, if you have questions on that, be sure to ask your teacher in class. All right, cool. The last type of problem, this one's kind of tricky. Okay, on something like number 7, we have a teeny little x right here, okay, that we want to solve for. And I know you're going, what is this? Why? Okay, what we're going to do is we are going to change this 64 to be 2 to the power of something. So I'm wondering, okay, how many 2's are in 64? Okay. So I know that 64, right, from our perfect square unit, I know it's 8 times 8. I know that 8 is 4 times 2, right? So I got a couple of those guys. And I know that 4 is 2 times 2. So look at this. I have 1, 2, 3, 4, 5, 6 2's. We're going to rewrite it just like that over here. So 2 to the 6th equals 2 to the 3x minus 3. Okay, So my goal is to figure out what x needs to be over here to get this. So what we can do is we can ditch the bases, ditch the big 2's, and just write the exponents. So 6 equals 3x minus 3. Now we just need to solve for x. We know how to do this. This is no problem. So plus 3 on each side. 6 plus 3 is 9 equals 3x. And go ahead and divide by 3 on each side. So x equals 3. That's how you do that one. You're just figuring out, okay, how do I, what would x need to be for me to get 64? All right. I know that last one was kind of weird, but I think you guys could totally do it. Go ahead and give H a try. Pause your video and do H now. All right, here's my work on H. You should have turned that 27 into a 3 to the third. Set them equal, and you should have gotten -1 for x. All right, that's all I have for you today. Again, be sure to ask your teacher.